Hey guys, it's Matt. I'm attempting to build Dave's Kwiky all-fuel burner. He's had a video out, and I'll link to his video in the description below. But the Kwiky, as Dave has explained it, is pretty much from here and up, and then he has his plug about here after the T, and I wanted to extend it a little further, and he built it with all 1/8 NPT brass pipe. I decided to go up to 1/4 inch to have this extension. I didn't want the tip. I didn't want the controls here being too close to the furnace by having such a small tip. So I opted to go with a larger diameter to keep the fuel running outside the nozzle. So I'll take this apart. It's just loosely fit, and I'll explain further as I'm going along. This whole piece from that T through to this T through to the nozzle will all have to be encased in this 1-inch black iron pipe. And I'm going to have to drill 2 holes through the side and 1 hole through the top to allow for this port in and the pressure gauge on the other side, and this is the fuel inlet. So currently I have a needle valve to control the high pressured air, so an air compressor will be needed, and I opted to put the pressure gauge, as Dave did, to find and fine-tune the air pressure to a good burn rate. So on this back end of the pipe, I went from a 1-inch coupling down to a 1/2 inch NPT, and then I purchased this 1/2 inch to hose pipe, or hose thread, 3/4 hose thread adapter, because I want a quick connect. So I want quick connect on the whole burner here, the fuel, and I'm not sure if the fuel quick connect, these are just airline quick connects. I'm not sure if this will restrict the flow in the quick connect. It won't really restrict the flow here coming through the quick connect on this side, the male, but the female might. And this is a hose quick connect with a ball valve. So my combustible air, I'm going to power it through just a hose, a garden hose, and that will just simply click and lock on along with the diesel, used motor oil, and compressed air on that one. So I'll just start spinning things apart, and you'll see how they kind of go together. So first I'll undo this. And that's just a manifold, aluminum manifold with 2 ball valves. The ball valves I might etch out with a pointer on the aluminum. at what point the flow is. I'll have to figure that out with testing, more testing. So this is just a street, and all this stuff, as I said before, it's all 1/4 inch. It does step down to 1/8 here because of the brazing or soldering. So I'll spin off the pressure gauge. And next I'll spin off the needle valve. And this is what will be left inside the burner tube. So I'll spin out the pipe. And now this will pass, that nipple will pass through the pipe. So I'll have to drill the pipe very accurately to the outside diameter of that nipple. So that's what has to get trapped. And then I'm going to cut the pipe off somewhere close to being flush, maybe an inch longer. I haven't done any calculations. I want to see how much the spray, because I don't want the spray actually touching the inside of that burner tube. So it's called a burner tube, but it's not supposed to have really any fuel burning in it. It's just supposed to be burning up to the mouth of it. So the next problem I have is that T-fitting won't fit. So I'm going to have to set it up and turn it around to fit inside the pipe. And to keep things center, so the inside diameter of that pipe is 1 inch 50 thou. So I will have to turn this to 1 inch 50 thou. And I will also have to turn this piece here on center of the 1/4 inch through pipe. So that will also have to get turned down. So in the end, that T will look a little bit like so. So then there'll be one set screw that drives this up against the inside of the pipe to keep everything central. Anyway, so I'll continue to take this apart. That's a 1/4 inch fitting, and that fitting I'll spin all this apart. This is Dave's design, I'm assuming. And there's nothing wrong with it. But as I said, I wanted more clearance around the pipe. Putting it through a 1/8 inch brass pipe didn't allow for any clearance. So you can see there's tons of clearance for fuel to go around. The pressurized air is coming in this side, coming in through the middle. And Dave did suggest to drill the end hole here, 3 32s, which is 94 thousandths of an inch. I drilled it number 54 drill bit, which is 55 thousandths of an inch. So I drilled it quite a bit smaller, 40 thou smaller than Dave's suggestion. But I did use the same, and I'm assuming the same MIG tip. He never stated what size hole, but he did show a package that he was using a 25 thou tip. So this tip, he suggested to solder this together, and all I did was drill and tap it, the tube. So I drilled and tapped the tube and just put a little bit of pink Teflon tape around it. So it's hard to see the thread, but that just got threaded in there. And on the other side, so that's a 1/8 NPT, and that's a 1/8 to 1/4. And then it goes into the 1/4 T. So like Dave did, I set my length, soldered it, cut it off, and sanded it flush. So you can see the solder ever so slightly there. I did have to drill out this tube, and this is what it looked like when I purchased it. So it's just a casting on the inside, and that 1/4 inch doesn't go through. The other thing, Dave, I tried to follow his video as much as possible, but he suggested turning this, and I'm going to quote unquote him, to a pretty sharp taper. I'm a little more precise, and the first setup, I guess I didn't have it sharp enough. The fuel was either flowing too much past or something was going on. So I tipped it down again, and that is set to 20 degrees, 21. So I was probably trying to hit 20 degrees. So that's the shape. So now I have to go off to the lathe, turn this piece round, which will end up looking something like this one. This was my test piece to see if I could really do it. So I'm going to turn that to the right diameter, and the T that was on the back side, I have to turn it to the right diameter. So stay tuned. When I get set up on the lathe, I'll show turning them.